Sound check, sound check. This is the MC's microphone. Can you hear us? Am I coming through?
ではちょっとこちらの方のマイク一旦切ります。
I'm turning off this microphone.
マイクです。マイクです。こちら登壇者用のマイクのテストをしております。1人目の登壇者のマイクのテストです。いかがでしょうか。マイクテスト。はい、はい、マイクのテスト中です。ただいま登壇者1のマイクを使って話しておりますが、ボリュームいかがでしょうか。はい、続いて登壇者2の方のマイクに移りたいと思います。登壇者2のマイクでお話、テストをさせていただきます。はい、こちら登壇者2のマイクのテストです。こちら登壇者2のマイクになります。音のほどいかがでしょうか。こういった形でこの後、お話しさせていただきたいと思います。マイクです、マイクです。ただいまこちらマイク2になります。マイクの2のマイク、マイク2の方の音声になります。もう一度、マイク1から、テスト最終確認させていただきます。はい、こちらがマイクのテスト、マイクテストです。マイク1の方のマイクテストとなっておりますが、どうでしょうか。はい、こちらマイクのテスト中です。こちらマイク1、登壇者マイク1のテスト中です。はい、では続きましてテスト2に移りたいと思います。マイク2に移りたいと思います。はい、こちら、マイク2の音声テストです。マイクいかがでしょうか。はい、これでマイクのテストを終了させていただきます。
司会のマイク、
はい、では、はい、今マイクのテストです。マイク1の方のチェックがいかがでしょうか。はい、こちらマイクのテストです。
We'd like to start as it is time. Good morning, ladies and gentlemen. We'd like to start the briefing meeting for reporters on the MASCOT release operation. The present status of operation of the Explorer and prospects will be given by Professor Yoshikawa. We'd like to have an explanation for about 10 minutes and then have a Q&A afterwards. Good morning, ladies and gentlemen. We'd like to thank you very much for coming so early. Without further ado, I'd like to talk about the MASCOT release operation, the present status. I'd like to briefly explain about the handouts on the MASCOT. For details, please come to our 15 hours meeting. We'll have a briefing on the MASCOT, the landing and so forth. The size is about 30 centimeters by 30 centimeters by 20 centimeters, and the lander is about 10 kilograms, and it'll be separated after this later today. There are 4 observation devices on the lander, and if you're interested, again, at 15 hours, we'll be giving you the details. Basically, the cameras will be used to photograph the surface spectrometry or weights and so forth. The surface temperature measurements will be taken. Minerva 2-1, compared to that, we'll be taking much more data, scientific data. And the lander, just once, is able to move, as is shown on this diagram. After this, it'll be separated and it'll land on the surface. It's a battery-operated device. 16 hours is the hours it has available for functions, and they will obtain data and send it to the Explorer, and it'll move just once, change its position once to collect data. The asteroid rotation is 7.6 hours, so twice as much. In terms of the asteroid day, 2 days worth of data will be taken. And the landing point.
So as you can see here, I think these are the landing candidates on the south hemisphere of below the equator, the southern side, in the medium latitude. These are the areas that we prefer as the candidates. It's dispersed over a wide area because it depends on the hopping, how much it moves by hopping. So according to the calculation, this is the areas that we should be looking into based on the calculation. And the same thing here again. The operation itself from on the 30th of September has started. So on Sunday, September 30th, October 1st, in these 2 days, the Explorer descent preparation was made. And then on the 2nd of October, actually yesterday at noon time, from that time, the Explorer started its descent, and the descent is making a steady progress. And just a while ago, it has come down to an altitude of 400 meters. And according to the schedule going forward, at around 11 hours, Japan Standard Time, the MASCOT separation release will begin. And so far, so good. I think the Explorer has been operated according to plan. In the case of MASCOT, after separation, as different from Minerva 1 and 2, after the separation, the Explorer will start ascend immediately, but it will not go back to the home position. Actually, around 30 kilometers at the altitude, it will stay once and hover around there. That's going to start from around 16 hours today, So it will hover at 3 kilometers point, and for 1 day or so, or as I said, 16 hours or so, it will maintain that position for about 16 hours so that it can maintain communication with MASCOT. So for the first time, this is going to hover at 3 kilometer altitude. And then after receiving communication from MASCOT,
MASCOT, and then it will ascend again and go back to the home position. And the home position return is estimated to be 15 hours of October 5th. So I just gave you the briefing as of this point, and the schedule, we are moving just according to the schedule as planned. Thank you.
We'd like to take questions at this point, so if you have a question, please raise your hand, and please state your name and affiliation before you ask your question. Please wait for the microphone. Person in the front. Yomiuri Shimbun, Tomiyama is my name. The scientific instrument observation, I'd like to ask about that. The spectrometric microscope is for mineral composition, investigation of mineral composition. What is the mechanism and what will you be investigating, please? In the bottom, it's at the bottom of the MASCOT, and it's near infrared Hayabusa 2, MILS 3, MR3. This is a microscope type of the same. It will come into contact with the surface, and they will expand the surface to measure the near infrared measurements to investigate the mineral composition. What do you mean exactly by mineral composition? Could you give us the details? Of course, there are rocks and sand, not much sand, but if you assume that there are rocks, the materials of the rock, what is the nature of the materials which comprise the rock? That is what we'll be investigating. And perhaps this question was asked before, but Hayabusa 2 will land, touchdown, and they'll collect material and bring this back to Earth. And perhaps this is complementary. What will be the MASCOT's role? It will be investigating mineral composition and composition and so forth. How does that fit in with the Explorer brought back materials? This is specific to the Hayabusa. We will be investigating at different scales. The Explorer does remote sensing from up in the air, the asteroid overall, and the distribution of material will be investigated. If samples are brought back, electron microscopes can be used to investigate. The MASCOT plays an intermediate role in terms of scale. It's between macro and micro. It will land on the surface and investigate. So the samples, most probably, what we can obtain is several millimeters. It may be smaller. In the case of Hayabusa, it was about 0.1 millimeter. So we can only obtain small samples, bigger samples of several centimeters. And the investigation and measurement of these can be done with the MASCOT. Thank you very much.
NHK, my name is Kinuta. Following up on the previous questioner, the spectroscopic microscope-based measurement, you will be investigating mineral composition. That's what you said. So, for example, what about the water composition? Will you be able to investigate that? Other than that, yes, the water itself is not going to be investigated. However, if there's moisture content, NILS 3, that 3 micron wavelength is used for that, for this near infrared, and the light level will be weakened. So that is a characteristic. So I believe the same thing can be done with micro omega. So with that, the microscopic mineral distribution based on that, the moisture level differentiation can be identified, I guess. So on the surface, if the rocks in the surface, do they contain moisture or not, can be investigated. That's correct, yes. In the operation of MASCOT, maybe you explained this earlier already, but from yesterday, Hayabusa 2 main body has started its descent, I think. And another thing is that with this MASCOT, is it possible to see whether there's gravity? By the measurement done by MASCOT, can you investigate how much level of gravity is there with Ryugu asteroid? The Ryugu gravity, the Explorer, when it approaches or when it recedes, the speed, by measuring the speed, I think it is possible to make an investigation. So after the bounces, several bounces, based on the bounce, I think the gravity can be measured in more precise manner. But what kind of bounces cannot be identified in a very precise manner. So MASCOT itself is not possible to calculate the gravity level of Ryugu, I believe. Thank you.
Nagayama from Mainichi Shimbun. This may overlap with some of the previous answers you gave, but the MASCOT operation this time is such that the JAXA and Hayabusa 2 team, what are your expectations on the part of those who have been involved in this? The surface scientific observation is what we're interested in. Photographs are such that Minerva 2-1 safely was able to take pictures and photographs, but data that can be used scientifically from the surface of the asteroid where we came into contact, we can obtain this, and this is scientifically very valuable. We have high expectations about the scientific data.
My name is Sue. Just if you know, let me know if you know. But the MASCOT said we can make a hop just once and make a move just once, you said. So you have given us the prospect locations, but how many meters will it be possible to move? I was also curious about that, so I asked Mr. Turami, the project manager of MASCOT. According to the parameters, just like Minerva 2, because there's a weight inside, and by driving that weight with a motor, it can make a jump. So the principle is just the same as Minerva number 2. But depending on how you rotate that weight, the distance varies, and you can set the distance accordingly. So from the landing spot to like several tens of meters away, it will move to that location, and we discussed about that possibility for observation. But most recently, I heard that it is not going to move that much, so only a few meters, or less than 10 meters, I believe. So a few meters, it will move, and then observation will be performed. I think that is the preference right now, according to what I hear. Because, as you can see from this table, or this chart here, once it makes a hop, and then it falls, it takes time for it to settle. And that is a loss of time, because the battery can last only for 16 hours. So they would like to make as much observation as possible and send as much data as possible. So that movement time is wasteful. That's the reason why they prefer a nearer location. And with a rim, it is also understood that the surface is quite even. So if the location is quite different, if the situation is quite different from location to location, it may make sense to make a larger distance, but it doesn't really seem to be the case. So I think it is better, it was deemed better to move to a nearer location. And just one other follow-up question, So this MASCOT can move and operate during the night hours. So this is not based on solar battery, I guess. So it's just a usual battery, I guess, for operation. Is that the reason why they can continue observation during night hours and day hours? Yes, that's exactly correct. So the solar power was considered to be a better approach. It was often said that solar power could be better, but solar power can only operate during the day hours, but we would like to receive data during the darkness in the night. And also when the temperature is so high, micro-omega cannot necessarily take good data. So that's the reason why we wanted to operate during the night hours as well, and that's the reason why battery was adopted.
NHK Kinuta. I forgot to ask earlier. The data will be accumulated by MASCOT. That's to measure magnetic field. What is the purpose of this, please? On the asteroid, whether there's a magnetic field or not, most probably there isn't. But I believe this is the first time. And if, for example, there's a small amount of magnetic field, this will be very helpful in exploring the development and birth of the asteroid. So that is why we have included a measurement of magnetic field. Most probably, I won't understand the details. The magnetic field and the birth of the asteroid, what is the relationship between the two? Well, we don't know, actually. So the fact that there is a magnetic field means that the surface material was melted and solidified in another planet, and it preserves the magnetic field that it got then. And maybe that could have been collected at Ryugu. Ryugu itself was not melted and solidified. Ryugu itself was an aggregation of debris, and so the debris was formed somewhere else in another planet, and then came. So the original planet information perhaps can be investigated from the magnetic field. Thank you very much.
Writer, my name is Hayashi. The spectral microscope, spectroscopic microscope, unless it's facing down, you cannot make any measurements. That is correct, yes. So if that is the case, once it lands, with the spectroscopic microscope facing down, I think the MASCOT will have to change its body out direction in order to face this microscope down. But when it's a rocky surface, if it lands in an awkward fashion, even if it lands in an awkward fashion, is it possible to face the spectroscopic microscope always down? Yes, exactly. The mobility unit that you see at the bottom there, and there's that represents the white that I mentioned. So that forms the axis, and with this axis, you will be able to rotate the lander. So this is the right direction. So if it is has the side, it's oriented to the sideways, or if it's upside down, by rotating the arm, you'll be able to change the direction and orientation of MASCOT. So it is possible. So there's no concern that there's no way of prohibiting the orientation change. So if it's stuck between the surface, but then I heard that you just have to hop. So it's not about just rotating. You will just jump and move to a separate location. That will solve the problem, I heard. So depending on how to swing the swing speed of the weight, it will be able to jump. And if it jumps to another location, we can expect that the orientation will be changed. So if it's, how do you know that if it's stuck in between the rocks or the surface? Because there's a camera, and the camera, in the first place, micro-omega data, if it's not the data is retrieved, I think we'll be able to understand that something is wrong. So if the data is not coming in as appropriately, then I will try to change the attitude, and then if it doesn't solve the problem, it will jump. So that's, I think, the protocol here. And another thing, so sorry for this rudimentary question at this point of time. So why is the reason you are going to collaborate with the German and French Institute for what is the historical background you have decided to align with them, and what is the significance of cooperating with these two institutes? Actually, we have a long history, so Hayabusa 2 in the first place, even before we proposed Hayabusa 2, so there was the original Hayabusa, and then before the launch of Hayabusa, the second mission after Hayabusa has been studied. So we called them back then Hayabusa Mark II. Then Hayabusa Mark II was considered to be quite different from Hayabusa first generation. So more advanced mission was contemplated back then. So Hayabusa Mark II was going to have a large lander of like 100 kilograms. So Hayabusa Mark II also was designed for a larger main body, but 100 kilograms of lander was contemplated, and European agencies are more advanced when it comes to the lander. So that's the reason why we have decided to cooperate with the European institutes, and then the name was changed to Marco Polo, and then it was ESA, but that proposal was declined. So in Hayabusa 2, compared to original Hayabusa, we have to do something more advanced, otherwise we won't be able to receive the budget. So according to our discussion with our European peers, the 100-kilogram lander was first the idea, but we have decided to reduce it to 1/10 to 10 kilograms. So according to that flow, Hayabusa 2, with our collaboration with our European peers, we have decided to equip this lander on Hayabusa 2. So the Asteroid Explorer, combined with a overseas lander, so can we consider that you have advanced to that level, being able to carry a European lander? Yes, the Europeans have given trust and reliability, have found reliability in Hayabusa 2 of Japan. So that's the reason why we're able. So what is the mutual benefit for both organizations? Yes, we, for example, if we are going to develop our lander ourselves, the budget will have to be much higher. And for us, the ESA, by collaborating with ESA, it's of course it's a single explorer, but we can engage in a more advanced mission. That's the benefit that we can. And for the European side, the lander that they have developed can be carried by Hayabusa 2, so they don't really have to launch a rocket, but still be able to explore the asteroid. That's a significant benefit, I believe.
The questions, please. The gentleman over there, please. Kato from Nikkei. During the operation of the MASCOT, if there are organic matter or moisture, water, is there a possibility that these will be confirmed, the existence of these will be confirmed? Yes. Well, what I talked about, the micro-omega and the near-infrared microscope, measurements are possible. As to specifically what the organic matter is, I believe it will be difficult to determine. We have to bring back the samples and analyze, otherwise it will be difficult. The moisture, whether there are minerals containing water or moisture, is something that we can know. To confirm once again, as to whether there are minerals that contain moisture, that will be announced. But as to whether there's organic matter, that we'll have to wait until it is brought back and analyzed. Yes, most probably that is the case, but I think it's better that I confirm with the MASCOT team. So later on, I'd like to confirm.
Arafune, another writer. In the solar system asteroid landing, Gerasimenko satellite of China, I think, is the last one. So after that, this is the second scientific observation. Is that correct to understand this mission? Yes, the solar system asteroid yes, that's correct for the Jupiter, I think. So for asteroid landing, scientific observation, this is the first time for the asteroid in the solar system. So that's the reason why you're expecting a lot of achievements and results. Yes, that's correct. And for MASCOT, MASCOT is going to make just one move, just one transposition, but is it due to the restriction of the battery? Yes, once it lands, and then it will start observation, and then once the data is sent, there's another some more time for it to move, and then do observation again, so that we can increase the amount of data. Thank you. Understood. Thank you.
NBS Kaneko is my name. Minerva, which descended first, based on the experience of descent of this unit to the MASCOT team, were there any feedback given? The MASCOT team, Minerva 2 and 1, the situation of these, they have a great interest in this. What they're concerned about is after separation, it lands on the surface. To what amount of time is required for standstill? Minerva 2 and 1, the accurate analysis is still underway. But after separation, in about an hour's time or so, it settles on the surface. The 1 hour's time is such that for the MASCOT team, this is what they envisage. A basic question, if I may. MASCOT's battery only lasts 15 hours. And if the position is not stable, can it autonomously settle itself and there will be no command from Earth? The MASCOT project manager said that it is able to make autonomous decisions, and if the position is not correct, it is able to move by itself. Thank you very much.
Once again, my name is Sue from Kyodo Press. Just for a reconfirmation, in my previous question, during the operation of MASCOT, you will not be able to understand the specifics of the organic matter. But so with the MASCOT-equipped devices, you'll be able to find out the minerals there, but the data will be sent to Hayabusa 2, and only after that is received at the Earth level, you'll be able to investigate and be able to identify. Yes, that's correct. So data, we'll be receiving all this data during this operation time, but once the battery runs out, it won't be possible to send the data. So we'll try to upload all the information to the upload during the 16 hours, and we'll try to transmit that data as much as possible to the Earth, but it depends on the propagation and communication environment. So it's not going to take months, but in a few days or time, I believe, or let's say 1 week or so, we'll be able to retrieve the data from MASCOT to the Earth. One more thing, I'm so sorry for the details, but in the case of Hayabusa 2, after Minerva 2, this is the second landing as a lander device, but in terms of procedure, is it quite different compared to the Minerva 2 landing procedure? The separation release operation, up until the point of release, it's almost similar to Minerva 2 and 1, but the last point is different. When at the last point of release, in the case of Minerva 2 and 1, in the horizontal direction, in the case of Minerva 2, the horizontal direction's speed is so high, so in order to cancel that, the Explorer had to maneuver itself to the horizontal direction to a little bit. But in the case of MASCOT 2, the release speed is so slow, so that horizontal direction maneuvering is not necessary this time around. But otherwise, I think the operations are quite same. But in the case of ascent, as I said, this will the home of the Explorer will go back to 3-kilometer position at the altitude level.
Uchu Writers Club. My name is Watabe. Page 8. On page 8, after separation, the Explorer looks like it's swinging the ONCT somewhat. What is this? Is it that the surface MASCOT is being searched? Is it looking for the MASCOT on surface? Yes, there is a scan. Altitude scan, ONCT and W is used to photograph the MASCOT. And the photograph, will that be brought down to Earth? What is the quickest time that it'll be able to be viewed? In the case of Minerva 1, we did the exact same thing, and the data was made available to Earth a day afterwards. In the case of Minerva, the subject was very small. It was a small point, whether it's Minerva or not, or whether it's noise. We need to check that, and we required some time for that. MASCOT is not very big, so we have to make judgments as to whether it's a noise or not. So that might take some time. Thank you very much.
Mr. Yoshikawa will have to go back to return to the operations. So one last question, please. My name is Akiyama, a writer. So this is the last question. This time around, micro omega, it may be possible to find mineral. So the NILS team, what kind of expectations are there from the NILS team? And what is the Europeans team? Because they have a track record on filler, so compared to this Ryugu, what is the difference between what kind of expectations do you have as to the difference with the past achievements? Yes, the micro omega data and the NILS 3 data, I think, are quite similar, I believe. Their NILS 3 is, of course, predominantly macroscopically they will observe the asteroid, and the micro omega is going to perform a microscopic observation. So that's quite different. So that's interesting. And the data with the difference with Europeans, I think, I'm not really sure about that, but there's a big difference between the asteroid and therefore, if one's data is available, so after that, I think this will provide a very important input to the scientific discussion after that. But the filler data and this data, the MASCOT team, how do they approach that? I think we haven't really heard the details from them. Sorry. Thank you.
This concludes the briefing and Q&A pre-separation of the MASCOT. Thank you very much to Professor Yoshikawa.